Welcome to the deep dive. We're here to take that dense, complex research and, well, give you the essential knowledge upgrade you need.
Because you're busy. You need to know what matters, and you need it fast.
And today, we are doing a really crucial deep dive into the foundational literacy of artificial intelligence.
Right, but this is not for computer science majors.
No, not at all. This is specifically for allied health professionals. We're talking physiotherapy students, occupational therapists, speech pathologists.
Anyone who's about to walk into a clinical world that is, it's just being digitized at an incredible pace.
The material we're pulling from today is from a core foundational text, Chapter 2, and it really gets at this central tension in education.
Which is that AI is completely everywhere, but, most students only really know how to use something like ChatGPT. They don't know how it works.
Or, more importantly, where it fails.
Exactly. So our mission today is to get you beyond just being a user of these tools and turn you into a really informed, critical navigator.
Yeah, I was really struck by how much the material insists this isn't about learning to code.
No.
The real literacy, it says, boils down to three things. First, getting your head around the core concepts. Second, knowing the practical tools for your workflow. And third, and this is the big one, defining the ethical lines.
That's it. AI is already embedded in everything you do academically, from researching a tough case to practicing a procedure.
So if you don't know the language, the limits, the evidence, you're basically flying blind.
You are. So this deep dive is your shortcut. It's what you need for responsible professional practice.
Okay, let's unpack this.
Let's do it.
To really get where we are now, especially with tools that can, analyze someone's gait or summarize a pile of medical journals, we have to go back.
Way back.
The source material says we have to start in the 1950s with Alan Turing. Why is his question? Can machines think? No, why is that still the bedrock for an allied health student today?
Because that one question, it basically set the ambition for the entire field. Even though the tools they had back then were, they were just laughable by today's standards.
Right.
Turing gave them the philosophical framework. He said, look, if a machine can talk to a human and the human can't tell it's a machine.
And for all practical purposes, it's intelligent, the Turing test.
Exactly. And that kicked off this whole exploration into how computers could maybe mimic human thinking. Spotting patterns, solving problems, all the things we now ask AI to do in diagnostics or education.
And that search for a definition, that's what led to the field getting its official name.
It did. In 1956, the Dartmouth Conference. John McCarthy, who we now call the father of artificial intelligence, he coined the term there.
And this wasn't just some casual get-together.
Oh, no, this was the formal beginning. This is when AI officially became a field of study, moving out of philosophy and into computer science.
So what were they focused on back then?
The early stuff was all about what they called symbolic AI, basically using human-defined rules, like simple logic trees, if-then statements, to solve math problems.
So you're saying they were trying to manually program in every single possible rule or scenario the machine might ever face.
That's it, exactly.
That sounds incredibly brittle and just so much work.
It was. And that brittleness, that's what led directly to what our sources call the AI winters.
Okay, what were those?
They were these devastating periods, mostly in the 70s and 80s, where everything just stalled. Funding completely dried up.
Why?
Because the promises were just way too big for the technology. The dream was to create systems that could reason like a human across all sorts of different areas.
But the tech just wasn't there.
Not even close. If you have to manually program every rule, you immediately run into what they call the common sense problem. A machine could be a genius at chess.
Because chess has a fixed set of rules.
Right. But it couldn't tell you why water is wet or why you shouldn't wear socks to the beach. You just can't program all of that unspoken common sense knowledge.
And I'm guessing the hardware was a major bottleneck, too.
A huge one. They just didn't have the processing power or the data storage to run anything truly complex. So the promises failed, and the investors, they walked away.
It sounds like a necessary low point, though, because when the comeback happened, it was huge. The first big moment that broke the winter was 1997.
Yes. IBM's Deep Blue versus Garry Kasparov, the world chess champion.
I remember watching that. It was a global event.
It was. And it completely cemented this idea that a machine could not only play at complex human strategy, but it could actually master it. What's important to understand, though, is that Deep Blue was still, a very narrow kind of AI.
It was just brute force calculation, really.
It was. But it proved that computational speed could beat human strategic thinking, at least in a very defined box.
And then came the real revolution, the one we're living in now. That happened around the 2010s. What was the big shift?
It was really a perfect storm of three things coming together. First, just massive amounts of data. The internet had been collecting text and images for decades.
So the raw material was finally there.
It was. Second, you had these powerful and affordable graphics processing units, or GPUs.
Which were originally made for video games, right?
Exactly. But it turned out they were perfect for running neural networks because they could do thousands of calculations all at once, in parallel.
Which is exactly what a learning algorithm needs.
Precisely. And that leads to the third piece, the huge breakthrough in machine learning and deep neural networks. So instead of programming every rule by hand,
The machine started learning the rules for itself by just sifting through all that data.
that's it. And that is what enabled the breakthroughs in understanding language and recognizing images that we just take for granted today.
Okay, so let's strip it all back. If you had to define AI for an allied health student who just needs to use it, what's the simple definition?
AI is just using a computer system to do a task that would normally need human thinking,
Like spotting patterns.
or understanding language, or solving a problem. For you, as the professional, the focus is purely on the application. You just need to ask, can this tool help me treat my patient or pass my exam reliably?
And the most obvious application right now, in 2025, seems to be this push for personalized learning.
Oh, it's the most immediate and, I think, a profound impact. Think about a student who's really struggling with something like neuroanatomy. It's notoriously difficult.
I can confirm.
Right. So instead of just reading the same textbook chapter over and over, an AI-powered adaptive learning tool can see, based on your answers, that you're weak on the cranial nerves related to Bell's palsy.
How does it know that? It's not just that I got the quiz question wrong, is it?
It's much deeper than that.
Yeah.
The algorithm tracks not just right or wrong, but the type of error you made. Was it a conceptual mistake or just a factual one? It even looks at how long it took you to answer as a measure of cognitive load.
And based on all that data.
It automatically serves up what you need next. Maybe it's a simplified 3D model of that specific nerve pathway. Then it gives you a few case-based questions just on that topic to really cement the knowledge right where you're weakest.
That level of tailoring is a massive time saver. It reduces that feeling of being completely overwhelmed.
It does. But it's not just for students. The material also talks about how AI helps educators.
By taking on the admin load.
Yes, generating practice tests, grading routine assignments, managing student progress data. All that automation is crucial because it gives the educator their time back.
Time they can then spend on mentoring, on hands-on clinical skills labs.
On fostering the kind of human judgment that an AI simply cannot replicate.
And that brings us right to the core ethical line in the sand, the one drawn by groups like UNESCO. AI must augment human intelligence, not replace it.
This is the absolute non-negotiable principle, especially in healthcare. The value is still the human practitioner. AI is brilliant at data analysis, at spotting patterns in a scan, but it has no real critical thinking.
It can't connect the dots with empathy.
Or ethical reasoning, or professional judgment. A physiotherapist doesn't just measure a patient's range of motion.
No, you're reading their body language, you're gauging their motivation, you're thinking about their life at home when you design an exercise program.
Precisely. All of that is contextual, it's empathic, and it's uniquely human. AI is an incredibly powerful assistant, but the final decision, that blend of science and wisdom, that has to stay with the human practitioner. Period.
Okay, so we know the history. Now let's get into the structure. The sources really stress that you have to know the different types of AI. If you don't know the category of the tool you're using, you can't really assess the risk.
That's the key. We have to stop talking about AI as this one single thing. It's not. It's a collection of different systems with very different capabilities and, importantly, different limits.
Let's start with the one we see most often, the workhorse. Narrow AI, sometimes called weak AI.
And narrow AI is exactly what it sounds like. It's a system built to do one specific thing. It's an expert in that one little box.
But if you ask it to do anything outside that box?
It fails. Immediately. Think of it like a specialist. In a university, the software that schedules clinical placements for thousands of students, that's narrow AI. It's brilliant at scheduling, but it can't write your essay.
And in a clinic?
A diagnostic algorithm that just analyzes blood markers to flag a risk profile. It does one thing, and because it's so focused, it's very reliable and predictable within that boundary.
That predictability is a huge contrast to the type of AI that gets all the headlines. Generative AI.
Yes, Gen AI. This is the game changer right now. These are the models like Gemini or Dell-E. And they're designed not just to analyze information, but to create new content.
So this is where a student asks it to generate a brand new patient scenario or design a poster on rotator cuff tears.
Exactly. The power of Gen AI is that it's so fluent. It sounds incredibly human. But, and this is the most important part, that fluency can hide a massive problem.
The hallucinations, the fact that it can just make things up.
Right. And students have to understand why it does that.
Mm.
A generative AI isn't thinking, it's not reasoning, it's doing an incredibly sophisticated form of pattern matching. It's predicting the next most statistically likely word or pixel in a sequence.
So when it invents a fake medical reference, it's not actually lying.
No, it's not. It's just making a really good guess that happens to be factually wrong.
Yeah.
It's optimized for sounding correct, not for being correct.
So the big takeaway for a student is,
Gen AI is an idea generator. It's a first draft tool. But its output requires mandatory, critical checking against sources you know and trust.
okay, let's touch on the simpler forms. Reactive AI.
This is the most basic. It only responds to what's happening right now. It has no memory of the past.
Like a simple FAQ chatbot on the university website.
Perfect example. You ask a question and gives you a pre-programmed answer. It doesn't learn from you. It's static.
And then one step up from that is limited memory AI.
This is where things start getting a little smarter. These systems can use recent past interactions to improve their performance over a short period.
Like the GPS in your car.
Exactly. It doesn't remember every trip you've ever taken, but it uses data from your current traffic accidents to adjust your route in real time.
And how would that look in an allied health context?
Think of a rehab app for a physical therapy patient. It tracks their reps and reported pain levels over the last couple of weeks.
Okay.
It uses that recent history to then suggest, okay, let's increase the resistance for the next session, or let's back off a bit. It's learning from the user's recent patterns, but its memory is limited to that one task.
So we've covered the practical AI that's out there right now, but the outline also mentions the more theoretical stuff, the science fiction concepts.
And it's so important to separate the hype from what's actually in your clinic. The big ones you hear about are theory of mind AI.
A system that could understand human emotions and intentions.
And self-aware AI, which is, a conscious machine.
And the sources are really clear on this. These are not real tools.
Not even remotely. They're completely theoretical. We have no idea how to build consciousness. So if you see some software that claims it can diagnose a patient's mood just from their voice,
You should be very, very skeptical.
extremely. Knowing the difference between the practical tools we have today, the narrow and generative AI, and these aspirational ideas is absolutely essential for being a responsible practitioner.
Right. So to get the most out of these tools, you need to understand the basic mechanics. Our source simplifies this into a really helpful three-step cycle: input, processing, and output.
I love this breakdown because it shows it's not a magic black box. It's a process,
Yeah.
and you can influence that process.
Okay, so step one, input. This is where the human comes in.
The input is your instruction. It's the prompt. It could be a simple question, or it could be a really detailed request like generate a quiz on hip pain diagnosis for a 40-year-old runner.
Then you have step two, processing. This is what happens inside the machine.
This is the complex part, but we can simplify it. The AI takes your input, breaks it down into numbers, and then runs it through its model, which was trained on, billions of data points. It uses algorithms to figure out what you're asking and find the most likely sequence of words that answers your question.
So when I type explain Bell's palsy, it's not looking in a digital medical textbook.
No, it's calculating the statistical probability of words like facial nerve and paralysis appearing together in a grammatically correct way after your prompt. It's a prediction engine.
And that leads to step three, output.
The output is the final product. It's the bullet point summary of Bell's palsy, the quiz, the feedback, whatever you asked for.
And understanding that three-step cycle, that the output completely depends on the input, really drives home the value of what the text calls prompt engineering.
Yes. And this is not a niche skill anymore. This is a core professional competency. If the AI is just a prediction engine, then you have to learn how to ask questions in a way that guides it toward the most accurate, relevant answer.
Can you give us an example? A bad prompt versus a good one.
Sure. A bad prompt is, give me exercises for back pain. It's too vague. You'll get a generic, probably useless list.
Okay, so what's a good prompt?
A good engineered prompt would be something like, act as a senior physical therapist, generate a differential diagnosis for a 55-year-old male with chronic low back pain. Include 2 red flags to rule out and present it in a SOAP note format for a third-year student.
Wow. Okay, that's so much more specific.
It is. You've given it a persona, an audience, constraints, and a format. You've forced it to narrow its predictions down to a very specific, clinically relevant pattern. Your results will be exponentially better.
You're learning to speak the machine's language?
To work with its strengths and around its weaknesses.
All right, let's quickly nail down some key terminology. To read the research, you need to know the language. Let's start with the big one, AI.
Artificial intelligence is the big umbrella term. It's any machine doing a task that seems like human thinking. The whole field.
Underneath that, you have machine learning, or ML. How is that different from that old symbolic AI we talked about?
Machine learning is the engine of modern AI. Instead of being programmed with rules, ML models learn the rules by finding patterns in massive amounts of data.
The old way, you'd have to write down the rules for what a cat is.
Right. It has fur, 4 legs, a tail. With ML, you just show it a million pictures of cats, and it figures out the pattern for itself. The source gives a great example of an ML model learning to spot gait abnormalities.
How does that work?
You feed it thousands of videos of people walking, some with healthy gaits, some with pathological ones. Over time, the model starts to identify the tiny subtle patterns, like a slight difference in step width, that are linked to a specific condition.
Okay, next term, natural language processing, NLP.
NLP is all about teaching AI to understand and generate human language. It's what lets your search engine figure out what you actually mean when you type a question.
Like Grammarly suggesting a better way to phrase a sentence in a report.
Perfect example. That's NLP in action.
And that brings us to the term we hear all the time now, large language models, or LLMs.
LLMs are just NLP on a massive, massive scale. These are the giant models behind tools like ChatGPT. They're trained on basically the entire internet. That huge scale is what allows them to generate such incredibly fluent, human-like text.
And finally, a really important one for PTs and OTs, computer vision, or CV.
Computer vision is the branch of AI that lets machines see, to interpret and analyze images and videos. For any movement-based profession, this is a total game changer.
How so? In a physical assessment, what does that look like?
We'll take something like a posture analysis.
Yeah.
Instead of just eyeballing it, a CV system can track specific points on a patient's body and give you hard quantitative data.
Like the exact angle of their trunk rotation during a functional test.
Exactly. Precise measurements that are just impossible for the human eye to capture consistently. It's moving assessment from being subjective to being objective and data-driven.
Okay, we've got the theory down. Let's get practical. Let's talk about the toolkit. The source makes a great point here. You can't just use one tool for everything. It's about matching the right tool to the right task.
Yes. So many students just default to ChatGPT for everything, and that's just not efficient or even safe sometimes. We need to break it down by function.
Let's start with the big one, writing and academic support.
Okay, so for just brainstorming or getting your head around a new topic, sure, ChatGPT is fine. But when you move to actual writing, you need more specialized tools.
Like Grammarly.
Exactly. Grammarly is more than a spell checker. It uses NLP to help you with tone, clarity, and making sure your writing is professional and concise. That's critical for patient notes.
And for research, that's such a huge time drain.
This is where tool choice really matters. Instead of a generic LLM, you should use something like Perplexity AI.
Why that one specifically?
Because its whole purpose is to give you summaries that are directly linked to its sources. It provides references. That forces the AI to ground its answers in verifiable information, which is a much safer way for you to start a literature review.
Okay, next category. Learning and revision. The core of being a student.
This is where adaptive tools are amazing. Quizlet AI is a perfect example. You feed it your lecture notes, and it creates custom flashcards and quizzes.
But the smart part is that it adapts, right?
It does. It sees which concepts you keep getting wrong, and it hammers you on those more often until you master them. It's like a personal tutor who knows exactly where your weak spots are.
What about for really complex problems?
There's a tool from Google called Socratic. It's great because it doesn't just give you the answer. It breaks down the solutions step by step. It teaches you the process, which is what you need for clinical reasoning.
And for just getting through those massive reading lists.
Google Gemini is excellent for that. You can drop in a huge chapter and ask it for the key takeaways in 5 bullet points. It just cuts down that initial cognitive load so much.
All right, what about presentations and visualization? That's so important in allied health.
For making things look good quickly, Canva AI is great. It can help you design educational infographics and posters from just a text prompt.
Takes the headache out of formatting.
It does. And for more formal slide decks, Tome AI can take a written report and automatically structure it into a professional-looking presentation. And for creating actual video content, Synthesia lets you make educational videos using AI avatars.
And finally, a huge one for clinical training, simulation and practice.
Simulation is where AI gives us a massive safety advantage. A tool like Labster provides these immersive virtual labs. You can practice a sterile procedure or a complex joint mobilization.
And if you mess up, no one gets hurt.
Exactly. You can fail safely, learn from it instantly, and repeat it until you have it down perfectly.
And just for day-to-day admin, capturing lecture content.
Otter.ai. It's essential. It transcribes lectures and meetings into searchable notes. It frees you up to actually listen and think critically in the moment instead of just scrambling to write everything down.
The source material calls this whole suite of tools the on-demand tutor.
And it's the perfect description. It really fosters your autonomy as a learner. You don't have to wait for office hours or feel embarrassed to ask a question. You have a partner that can give you immediate, tailored feedback whenever you need it.
Okay, so we've seen how powerful these tools can be. Now we have to look at the other side of the balance sheet. To be a responsible professional, you have to be crystal clear on the benefits, but even clearer on the risks.
Absolutely. Let's start with the good stuff, the aha moments. The personalization and efficiency gains are just transformative.
Let's dig into personalization. How deep does that really go?
It keeps you in what educators call the zone of proximal development. So if you've mastered shoulder anatomy, the system will accelerate that content and spend more time on, say, the wrist and hand where your scores are lower. It keeps learning challenging, but not impossible.
And efficiency. This is about saving time.
Hours every week. A tool that summarizes a dense chapter or makes your flashcards for you, that's time you're not spending on low-level information gathering.
It's time you can now spend on higher-level thinking, like analysis and application.
Exactly. Then there's improved writing. Clear communication is a core competency. These tools help with structure, clarity, and getting your citations right, which is a huge relief for many students.
And finally, enhanced visualization.
This is about making concepts real, moving them from a flat textbook page into a 3D interactive model you can manipulate. For understanding something like complex joint mechanics, that's just a massive leap forward for retention.
Okay. Now for the limitations. The source is very clear. AI is a tool, not a substitute, and this is where we need to be vigilant.
We have to start with the biggest danger, accuracy issues. We talked about hallucinations. The AI is designed for fluency, not for truth.
So if a student asks an LLM for a treatment plan for a complex patient and doesn't check it,
Then we're taking an incredible risk. You absolutely must have a verification mindset. The output from an AI is a first draft. It's a hypothesis.
it's not a clinical guideline.
Never. Every single piece of clinical information has to be cross-checked against a trusted source, a peer-reviewed journal, a hospital protocol, something you know is vetted.
And that accuracy problem flows right into the next limitation, a lack of true understanding.
This is so critical for clinical reasoning. The AI can pull together statistically likely words about rehabilitation, but has no idea what it feels like to be in pain. It doesn't understand the patient's culture, their fears, their life situation.
So it can give you the textbook answer for treating a stroke patient.
But it can't integrate the messy reality of that patient's life. The human practitioner does that. And if you rely too much on AI for practice, you're not developing your own independent critical thinking.
Okay, limitation number 3, the risk of plagiarism.
It's a huge temptation.
Mm-hmm.
The text is so good, so fluent, it's easy to just copy and paste. But that's academic misconduct, and it short-circuits your own learning. You have to use it as a drafting partner, not a ghostwriter.
And the fourth limitation, which is maybe the most serious in healthcare, privacy and security.
This is an absolute red line.
Yeah.
You cannot put confidential patient information into a public AI tool like ChatGPT.
Because they often use that data for training their models.
They do. So if you enter case details, even if you think they're de-identified, you could be violating strict privacy laws.
Yeah.
It's a massive breach of professional ethics. Patient data can only go into specialized, secure, encrypted systems designed for that purpose.
And finally, the fifth limitation, bias.
People assume algorithms are neutral. They are not. An algorithm is just a mirror of the data it was trained on.
And if that data is biased,
The AI will be biased. Think about that computer vision for gait analysis again. If it was mostly trained on videos of young, able-bodied men,
It's not going to be very good at assessing the gait of an elderly woman or someone with a different body type.
Exactly. It might flag a normal variation in her gait as being pathological just because it's different from the data it was trained on. You have to be constantly on the lookout for how bias might be showing up in the AI's output.
We have covered so much ground today, from the very beginnings of AI in the 1950s all the way to the critical limits you need to be aware of in 2025. It's clear that AI literacy is not an elective anymore. It's a core competency.
Let's just boil it down to the key takeaways for you, the learner. First, think of AI as a support system. It gives you efficiency, it gives you personalization, but it never, ever replaces your clinical judgment or your empathy.
Second, know your tools. For your daily work, it's mostly narrow AI for specific tasks and generative AI for brainstorming. Knowing the difference helps you manage the risk.
Third, remember that quality in equals quality out. Prompt engineering is a real skill. Get good at writing specific contextual prompts to get more accurate results.
And fourth, and this is the big one, you have to be vigilant. You must verify every output. You must uphold academic integrity. And you must protect patient privacy at all costs.
When you stick to those principles, AI becomes this incredibly powerful study partner. It strengthens your clinical knowledge and your digital literacy at the same time, which is exactly what you need to be a competent, adaptable professional.
So since we know that critical thinking and digital literacy are now just part of the job in allied health, we want to leave you with one final thought to think about.
Considering that AI's big promise is efficiency, what's one specific task in your daily routine, either studying or in the clinic, that AI could responsibly and safely automate for you?
And on the other side of that coin, what is the one task that must always remain solely in human hands to protect patient safety and to preserve that essential human element of compassion and connection?
Think about that line between technology and humanity. We'll see you next time on The Deep Dive.